Okay, hi guys. So in this lecture, we'll be discussing on the characteristics of Hoffman bromide reaction. So let's start it. So characteristics are first would be that 1 mole of Br2 and 4 mole of the base, which is OH minus, is consumed in this reaction. So 1 mole of Br2 and 4 moles of base, which is OH minus in this case, is consumed in this reaction. Okay, second point would be that migration is the redetermining step. Okay, third point is that 2 degree and 3 degree amides will not undergo Hoffman bromide reaction. Okay, so if I want to if I need to explain this more, so more the migratory aptitude, more will be the rate of Hoffman bromide reaction. Okay, so more the migratory aptitude, more will be the rate of Hoffman bromide reaction. Okay, so we have to discuss next the migration in intramolecular. So intramolecular migration. So obviously the migration in this case is all intramolecular, and we need to discuss on this example for what would be the product formed after the molecular migration. In these two compounds we have a mixture of this and this NH2, and let's say it has a deuterium in place of hydrogen. Okay, and we are using 2 moles of KOBr. Okay, so what would be the product formed? Product formed would be something like, in this case we would have the formation of N15H2. Okay, this would be one of the product, and in this case we would have something like NH2 and D. Okay, so we won't be having such products like we have D here and N15H2, or we won't be having something like NH2. We won't be having these two products. Why? Because it is intramolecular. If one comes and thinks that this group can get attached to this nitrogen atom, that won't be possible, that will not be possible. And if one comes and thinks that this group will migrate to this nitrogen atom, this would also not be possible, even if they are in a mixture. Okay, this only intramolecular, where this will migrate only to this nitrogen atom and this will migrate only to this nitrogen atom. Cross migration won't be there, or intermolecular migration won't be there. Okay, so next point in the characteristic only is the fourth point. We have something like migration is intramolecular. Okay, okay, so what I'm talking about KBr for the first time, KOBr for the first time. So KOBr is nothing but when KOH reacts on BR, the O minus actually attacks on Br plus, and we have something like OHBr, and KBr would be again on this, and obviously KBr would be formed, and again on this HOBr, KOH again attacks, and as a result water molecule will be out of this reaction. As a result, we'll have K plus and OBr minus, so we'll have KOBr. Okay, so this is the formation of this reagent, which is KOBr. Okay, and another is that 2 degree and 3 degree will amides. Amides will not undergo Hoffman bromamide reaction. Okay, now let's take on some examples on the same concept. We have something like this compound, okay, amide, okay, and we reacted with KOBr. What would be the product formed? Obviously this group would be converted into NH2 group. We would have something like this. Okay, second example would be, we have something like F here and NHBr, and we have KOH. Please don't confuse that this is a 2 degree amide. This is not a 2 degree amide, it is very much a 1 degree amide, and this is the intermediate which is also formed in the Hoffman bromide reaction of 1 degree amines, and hence no problem would be there. This would be living as the reaction progresses, and we would still get NH2 and F on the ortho positions, relative ortho positions. Okay, third we have something like ET CO NH2, and we reacted with KOBr to form product A, and which will be reacted with CHCl3 in presence of KOH to form product B. Okay, what are products A and B? A is definitely EtNH2, okay, and B would be nothing but nitrile. Okay, we have discussed it so many times in the previous lecture. Okay, I hope you remember all the concepts from the previous lecture as well. Please do keep revising all the name reactions as well, because as we go on, the number of name reactions will keep going on increasing, so you'd have a hard time remembering all these. When in exam time you will be bombarded with all the name reactions at a go, just like in these two examples we have. Okay, so do keep revising their mechanisms, do keep writing as many times as possible all these mechanisms, so that they occupy a permanent place in your mind. Okay, so questions like this will actually help you brush up all these reactions which we have seen in the past lectures. Okay, so what will be the product A? Product A would be nothing but O would be acting, forming a double bond, and will be evolving as a SO2 gas, and hence we will be getting something like a acid chloride and a Br group also attached to it at the meta position. Okay, so I just rotated it. I hope you don't get confused. What would be the B product? B product would be nothing but, when we are reacting it with NH3 in presence of heat, we will get amide. Okay, so B product would be a amide. We'll have something like NH2 here and Br at meta. Okay, what happens in C? Obviously it is Hoffman bromide reaction which we are currently seeing. Okay, so this would be the product C. Now what would be the product D? D product would be nothing but formation of isonitrile, which is a test for 1 degree amine. So isonitrile would be formed. I beg your pardon, this is only two bonds and one complete donation is shown. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more on we'll be revising. I think it has been too much for you guys, so I think we'll be revising all the concepts in the next lecture, some important aldehydes preparation mechanisms, and then we'll be seeing Lidnard catalyst. But just before going, let me discuss one more problem. So we have something like this, and we are reacting it with NH3. We are getting product A, and product A will again react with KOBr to get product B. What are A and B? So by now, by this you will be easily able to see that product A would be nothing but I beg your pardon, this is not a phenyl ring, this is still R, so R CONH2. And what will the product be? Product B would be nothing but RNH2, the basic or the simplest conversion or the reaction which is called Hoffman bromamide reaction. Okay, so with this we come to an end of this lecture. So till then, good luck and goodbye.